All right, everybody, I have the top of the hour on my clock, so we are going to get started. Hope everybody is staying warm on this very, very chilly Tuesday, especially if you are in the US. It is not warm right now, so I hope everybody has some good heaters or at least some good blankets to cover under. But we're going to get started. So we are talking about using the GEOWEB soil stabilization system for resilient and cost-effective stormwater channels today. So I am Sam Justice. I'm your host, and I am licensed as a professional engineer in the states of Wisconsin and Kentucky with degrees in both civil and geotechnical engineering. I am one of the engineers here at Presto Geosystems, and we manufacture erosion control, stormwater management, and porous pavement products, all made in the upper Midwest of the United States. Through an extensive national and international distribution network, we offer technical and site support, as well as free project evaluations from our in-house engineering team, like myself. So some learning objectives, what we're going to cover today is we are going to start with a good look at the GEOWEB system, what it is and how versatile it can be. Then we're going to look at how it can work for some different situations, including some pipe outfall areas, high flow situations, that sort of thing. And also we're going to look through some of the university accredited research that has been performed with the GEOWEB system. So just so you know, you can put the questions in your questions tab. So if I don't answer anything, or if you think of it before I get to it in the presentation, feel free to put it in that questions tab, and there will be a Q&A session at the end of the presentation. So a little bit of background about Presto Geosystems. We worked with the US Army Corps of Engineers to develop the Geocell technology in the late 1970s and have been innovating in the geosynthetics market ever since. Our products have been used in nearly 200 countries and in every state in the United States. We go beyond simply providing a product, all with an eye toward providing a complete solution for your specific project. So at Presto Geosystems, we do operate in three main product areas. We have our GEOWEB Geocells, which can be used for load support, slope and channel protection, and then also constructing green retaining walls. And then we have a line of porous pavement products, both vegetated and stone surface solutions. And then finally, lightweight, reusable construction mats. Today, we are going to be focusing on the GEOWEB system, specifically channel applications. First, I do want to go through a pretty general overview of what the GEOWEB soil stabilization system is. For those who might not be familiar with this type of product, like I said, started in the 1970s, but still a little bit unknown in some areas. So I want to make sure we're all on the same page. The GEOWEB system is our version of the Geocell technology, and it consists of two main attributes to be aware of. The first is going to be the cell or the container size. The cells come in three diameters, small, medium, and large, along with cell heights between 3 and 12 inches. And these dimensions are going to depend on your project specific details, if you have vehicle loading requirements, what your slope angles are, that sort of thing. So we can help you determine which one is going to be the most appropriate for your specific job. There is no one right size fits all. Another thing I want to point out is the ultrasonically welded seam, and that's where all of these connecting points are. The stronger your seam strength, the better the performance the Geocell is going to have. A strong seam allows for heavier infill materials, steeper and taller slopes, and better overall lifetime performance. The GEOWEB panels are produced using a high-quality virgin, high-density polyethylene, HDPE resin, for consistently strong welds at every cell junction, while also maintaining semi-rigid ductile properties within those cell walls. If you have too stiff of a cell wall, it can lead to overstressing of the seams and the potential for cell rupture or failure. So our Geocells do not use any fillers or exotic polymer alloy blends, which can ultimately reduce your weld strength and other components such as your environmental stress crack resistance, your ESCR. These types of things, the fillers, alloy blends, that sort of thing, are sometimes offered in some of the competing products that are out there in the name of increasing the cell wall stiffness. So to avoid weld failures and the damaging effects of differential settlement, uniformity in performance across all the elements of a geocell system is going to be much more important than focusing on a single characteristic such as cell wall stiffness alone. The second attribute that I want to mention for the GeoWeb system is going to be the infill materials, what you're putting into every one of those containers. So there are three main infill types that can be used with the GeoWeb system, depending on the type of protection that you need at your site. You can use topsoil, aggregates or other granular soils, and then concrete. So in most cases, this is going to allow for the use of on-site, salvaged, or site one materials. You can reuse what you've excavated without the need to import fill. So all three types can be used for channel protection. Typically, we do see topsoil as the most common. Usually for aesthetics, you get a nice green slope, green channel, looks really nice. But in some conditions, such as where you have very high flows, concrete might be the best option. So again, there is no one right answer as to what the infill type is. It's going to be what is best for your specific project. And I do want to mention that the GeoWeb panels and all of the accessories that we're going to talk about in just a moment are 100% made in the United States under strict quality assurance and environmental control processes, sure to comply with any requirements in the Build America, Buy America, and the Infrastructure Investments and Jobs Act, IIJA. So if you are looking to get maybe federal grant money, if you're looking to try and to match one of those requirements, if you do just have, made in the USA requirements, that sort of thing, all of our products do meet those standards and can be used and are considered qualifying products for those type of applications. And something I do want to point out here is this is our standard performance and material specification. This is a one-page summary of it. So you can see that there is a lot of information packed into our standard spec sheet. We don't have time to go through line by line, but I do just want to let you know that this should be the sense of what you should get with a typical Geocell product spec. So you'll note that it contains a lot of details about key material properties, including that weld strength and ESCR that I had mentioned earlier. And then a general note when you review any product spec sheet for geocells or really any geosynthetics is that you want to pay attention to see if there's any disclaimer language, any of that fine print, usually at the bottom of the page. Something that we've noticed recently, it's a concerning trend in the industry as a whole, is where low-end product providers will present performance data that appears to be equal to the industry accepted standards at first glance, but then they add a disclaimer along the bottom in fine print saying something like specifications can change without notice, or information is for general purposes only and not intended for design. Things that basically say, we don't have to meet these specifications every time. And so you just kind of want to have a heads up for that. Watch out for that type of trap, especially if you get hit with one of those requests from your contractor to put an or equals product in or do a substitution. You really just want to make sure that you're going to get a product that's going to meet the standards that it needs to in order to perform properly. So our spec sheet contains no disclaimers, no fine prints, and we stand behind our numbers so that you can deliver certainty in a solution as you build with materials that you can trust. All right, so we do offer a complete system solution for our erosion control products. So it's more than just the panels themselves. The system components are all going to be the supporting accessories that allow for a stronger and faster installation. These are things that only we offer, but that make this system function the way it's supposed to and be the industry-leading standard that it is. First one I want to mention is going to be the ATRA key, and that's A-T-R-A, ATRA. And it is our first component for a completely integrated system. It connects each individual panel of the GeoWeb into a single web that covers your entire project area. It allows for faster installation of the panels and will last the lifetime of the project, ensuring that your area, your channel, is protected and that the GeoWeb system is not going to fail under the anticipated loads, whether that be vehicle loads, water loads, hydraulic loads, anything like that. So the specific engineering values of the ATRA key will ensure that the system holds up to loading over time without the corrosion that are seen with metal staples or the failure of underperforming cable tie systems. So there are competing products out there. They do have other connecting mechanisms, but they are just not as strong, not as long lasting, a lot more difficult to install, that sort of thing. So just something to keep an eye on, especially if you do see those substitution requests. So the next thing we want to look at is going to be your anchorage options. So when the GEOWEB panels are laid completely flat, the anchorage is really not needed. The panels are just going to hold themselves to a flat surface. But as your slope angle increases, you do have to worry about slumping or sliding down to the toe. You don't want that. So for shallow slopes, so think a 2 horizontal to 1 vertical, about 26 degrees or shallower, you can use stake anchorage as your option. That's usually going to be sufficient. We do have 2 options for stakes. One is made with your standard steel rebar. The other one is made with HDPE, the same as the panels. That's what's shown in the photo here. We call it our ATRA speed stake. So if you are in a saline environment, maybe you're along a coastline where you're worried about corrosion, the ATRA speed stake is going to be a lifesaver compared to that corrosion-prone steel. And stakes can be driven either by hand or by power drill for easy installation. So if you know you have a lot of stakes to put in, maybe get a drill, save yourself some hammering work. So if you do have a steeper slope, if you're going steeper than a 2 to 1 horizontal, you can go with the tendon system. This is also great if you are going over a liner. If you have some sort of geomembrane liner that you don't want to puncture, going with the tendon system gets you away from stakes. Stakes would puncture the liner, obviously not helpful. But so the tendons are a great option because they are a load transfer device. So they carry the load from the panels all the way up to the crest of the slope and are carried there by some sort of crest anchorage system. Think a dead man pipe, earth anchors, that sort of thing. And so the ATRA tendon clip, which is very similar to the ATRA key, but is made specifically for this tendon anchorage system, is designed to fully transfer the forces that are placed on a geocell. And all of our accessories, the ATRA key, the stakes, this ATRA tendon clip, are designed and tested specifically to work together with the GEOWEB panels so that we can go from problem to cross-section to construction solution with a system where the modeling replicates the real world forces. So this isn't an estimation. These are things that we know are going to work based on what actually happens out in the field. I do want to do just a really quick diagram here. Let's just sort of walk ourselves through this, make sure now that we've talked about all of these things, we know how they're actually used. So I also want to sort of stress when I say channel, I'm going to be saying that a lot as we move forward here. I'm talking about protecting any type of area that includes the full width of a channel. So your channel bottom plus side slopes. You could do just the bottom plane of a channel, just the side slopes. Maybe you've got an embankment or a dam structure. Basically anywhere that's going to see some version of a hydraulic load, we're calling a quote unquote channel. Okay, just making sure we're all good on that. So we have our standard channel here, standard dimensions, nothing fancy. Depending on what infill material you choose, we may recommend the use of a geotextile separation layer. Typically, we see these when there's a concrete infill. Sometimes it's necessary in other situations too. Again, that is something we can help determine on a project by project basis rather than a yes, you always need it or no, you don't always need it sort of thing. Next, you would place the GEOWEB panels themselves. They would go directly on either the natural channel soil or on that geosynthetic layer if you need it. You do your anchorage options. Again, you have 2 options. The first being those stake anchors, the ATRA anchor, or you can do the tendon system where you need some sort of crest anchorage, like I mentioned, a buried dead man pipe, earth anchors, that sort of thing. You would put in your infill. Again, you can choose between topsoil, a granular material such as stone or concrete, and then you're good to go. Allow that water flow to come through and you have a channel. So lots of different options, lots of different things to go through. But this is something that's why I'm here, and the rest of the engineering team here at Presto is here to be able to help you through any of the questions you might have about a system like this. And so the GEOWEB system is designed to create that stable channel surface, even when you do have your maximum velocities and maximum shear stresses occurring. So there are two ways of building up the GEOWEB protection system. The first is going to be what we call a single layer system. That's where the GEOWEB panels are laid directly on the channel, on the bottom, on the side slopes. They're directly on sort of the native soil of your channel or embankment. And so this is great for areas where the slopes are a 1-to-1, so 45 degrees or less, but also as long as basically you have room for your footprint of your channel, this is going to be the most efficient way of protecting against erosion. But sometimes your space is limited, or the project area is maybe up against existing structures, like this home in this picture that you just can't move, you can't lay back that slope. So when those side slopes are nearly vertical, the GEOWEB panels can be stacked on top of one another to create a retaining wall on one or both sides of the channel. The GEOWEB retaining walls can still withstand the same velocities and shear stresses as that sort of single layer channel, and they're still flexible enough to handle curves and changes in grade. So the retaining walls are not meant to be a limiting factor. They're meant to be a new option that you might be able to use. So this is a great way to deal with making deep channels, or if you have very steep side slopes, all the way up to 80 degrees if necessary. And there are lots of options for mixing and matching how the GEOWEB panels are placed. So you can have a single solution for even complex sites. So just a great way to sort of highlight the flexibility of how the GEOWEB system can work. And one more accessory, because we don't have enough, right? But one more thing that really helps pull everything together with the GEOWEB system is the Atra wall key. So this is a new design that we've made that's made specifically for these retaining wall type of structures. And they're intended to be the color of the fascia and are large enough to completely cover the slot that's necessary to hold all of the different panels together to create a more aesthetically pleasing wall immediately after construction, but prior to vegetation growth. So it just helps hold everything together, makes it look a little nicer, and again, is designed specifically to work with the GEOWEB system and make us one of the industry leading standards for how these type of systems come together. All right, so we've now done our good basic overview of the GEOWEB system for its embankments and channels. So let's dig a little bit deeper into the capabilities and functions of how each infill type works. So we're going to start with vegetated infill. So this is where you're going to get your grass surface. So one of the best things about the GEOWEB system is how much trust we have in that the system working for your project. That's because we have the experience and research to back up what we're saying. A huge series of tests were completed at Colorado State University in Fort Collins, Colorado, under the direction of Dr. Chris Thornton. CSU is considered one of the top hydraulic research facilities in the world. And the facility is unique. It's kind of cool because it's located underneath the Horsetooth Reservoir in Colorado, and it's a couple hundred feet of static head. So it can achieve extremely high velocities and shear stresses in both their indoor and outdoor flumes. So this is a great place to do testing for geosynthetic research. We started with vegetated testing, and it was performed with two different objectives in mind. The first was the ability to withstand high velocities and high shear stresses, the main components that you're thinking about when you're trying to withstand that water flow. But the second objective that we wanted was to compare the performance of topsoil filled GEOWEB panels versus riprap or other conventional solutions, such as erosion control blankets by themselves. So the testing consisted of using a 6-inch deep GEOWEB panel filled with topsoil, and in this case, they also did a surface protection. They did a turf reinforcement mat over top of the filled panels. And this is probably our most recommended cross-section for this type of application, so that's why we did the testing for it. And vegetation was established and grown to about a 6-inch deep grass section. This is going to replicate your typical field conditions where all that grass and all that vegetation is fully grown in and giving you that protection. So testing consisted of 10 one-hour tests, which were performed in the outside flume at Colorado State University under varying conditions, including adjustable flow rate and bed slope angle. So the testing was done in accordance with ASTM D6460 standards, which covers both soil loss through scour and overall blade density. So the ASTM standard considers a successful test when you have less than a ½ inch of topsoil loss and at least 300 blades of grass per square foot after the test is completed. Blade density is important since it doesn't really help if the soils stay in place, which is good, but then there's no grass growth, which is bad, because then you're just ending up with a muddy looking channel, which is not the point. But we can say vegetated channels do hold up very well against even turbulent flows, such as around corners or near rough terrain. Most people would think a vegetated channel can't actually handle significant water flow, but when it's properly confined in the GEOWEB system, along with a surface protection method, velocities of 30 feet per second and shear stresses of 16 psf can be achieved. And so this is actually one of the tests, that photo there. The GEOWEB filled with topsoil and grass is underneath all of the water in that flume. You can see the water is deep enough that you can't even really tell that there's anything underneath it, but I promise it's under there. And so obviously there are lots of different types of grasses that you could choose to put in here. If you choose a hardier variety, that is going to help. But really the more important thing is to choose something that you know is going to grow in your area and in your climate, something that's going to blend nicely with the area surrounding it so it doesn't look super odd. You know, I'm not sure you want to put Kentucky bluegrass if you're in New York City. You know, that's not necessarily going to look cohesive. It'll work, it'll function, but you know, it's just it's going to look a little more obvious, I guess is what I'm going for. All right. So what we did determine is that when you pair the GEOWEB system with a surface protection method, you can resist extremely high flows, again, up to 30 feet per second, and those shear stresses of 16 feet per second. And so compare this to an allowable 4 feet per second when you have unconfined vegetated channels, so when you just have a natural soil channel. And so you can see that's a massive improvement. The surface protection, in this case, this was a TRM, it prevents the soil from scouring out of the cells, while the GEOWEB prevents those super saturated soils from washing downstream during your high flow events. So it's a good combination to have both, and that is why it is our most recommended cross section. But you can get those really, really great results. 30 feet per second is massive. And then this is what a typical application using the GEOWEB system is going to look like. This is alongside of a highway, and it's compared to, you know, the typical riprap system that you would see. Ripraps tend to look unfinished. They are just stone laying in dirt. And so they do need maintenance, usually after every major storm event, to ensure that there hasn't been significant loss of material. With the GEOWEB system, you get this nice looking green area, and you can be assured that it's still going to look this good even after a big storm. The system also works great for embankments. In this case, this was an embankment on the dry side of a pond, and that would see frequent overtopping. It had some pretty unstable soils because it was actually an active gold mine in northern Canada. So it had some variable slope lengths, some variable face angles, so it needed a flexible system that would be able to cover all of that in a single protection method. So northern Canada is definitely a cold weather environment. And so the GEOWEB system actually stands up really well against cold. It does well with snow, frost heave, ice buildup, any of that stuff. So you can allow for that ice buildup to happen. You can let the snow fall on it, anything like that. It's not a concern. The GEOWEB panels themselves are not going to become brittle and break in cold weather environments. They are able to withstand that. So you don't have to worry about it, you know, cracking or anything if it does get very cold, kind of like today. So those cold weather environments are not meant to be a concern. It shouldn't be, again, that limiting factor. So, and in this case, an access road was also being built above the embankment where that excavator is currently shown. So the slope had to be stable enough to support the expected traffic live loads as well. And so when using the GEOWEB system as an embankment, the GEOWEB panels protect the slope from water runoff and overtopping with no loss of vegetation. So you can grow that grass and water can flow over from that access road without causing erosion, without causing undermining of that access road. So this is another great thing about the GEOWEB system is when you do have space constraints. So if you've got, like in this case, an access road at the top of the road, but maybe you have another one at the bottom of the road, or you have other infrastructure such as bridges or trees, fencing, anything like that that you need to be able to work around, something that says I can't lower the grade of my slope, I have to work with this steep slope. Put the GEOWEB system on top of these steep slopes so you don't have to worry about erosion, and you can work around and with existing or new build infrastructure. So you can have that guardrail at the top. You can go right up against those bridge abutments, anything like that. So you have a lot of that flexibility in working in the space that you have, so you can try and minimize the amount of additional work that you might need to do. This is another common application. This is alongside of a road. This was in Ohio. Shows, our pretty common concern where there's erosion and washout that falls down onto the road, potentially causing road closures during major storm events. So covering this slope with the GEOWEB system, filling in with topsoil, allows for that vegetated slope without the concern of having to constantly come and replace that soil every time it rains. We do recommend that sort of surface protection. In this case, they went with hydro seeding. And this allows the GEOWEB panels to get that vegetation growth, gives you that chance for the grass to grow in before a big rain event happens. Also, hydro seeding helps get that grass growing a little bit faster, that sort of thing. So this is definitely a really common application. We're more than happy to talk about how this sort of thing can work for you. Vegetation along shorelines, very important when we're talking about stormwater channels. So placing the panels along a shoreline is going to help against wave action erosion due to that water movement, wave action, that sort of thing. So this was a project along a stormwater diversion channel that actually helps move hurricane waters. It was down in Florida. So during the hopefully infrequent hurricanes, the channel would flood, and then every time it would flood, it would cause pretty severe erosion along those side slopes. And you can see that there is existing infrastructure all the way around this channel. So the city was actually trying to come up with this solution to keep the water within its banks without having to constantly come back, rebuild up those side slopes after those hurricanes, because frankly, they had bigger things to worry about. So the GEOWEB panels are placed both above and below the normal water line in this type of project. So the panels should go below that water line to ensure that they don't get lifted up due to wave action. And that way you're protecting your entire shoreline slope all the way down to the channel bed. You don't have to cover the channel bed, especially if it is always covered in water. You do just want to cover that side slope. And you don't actually need to do dewatering. You can see these guys here are working in a fairly flooded channel, so you don't have to worry about having to put in a cofferdam or anything or dewater one of these channels to do this type of installation. The GEOWEB panels themselves will sort of initially float, but then you can anchor them down either with stakes or some other weights going to hold it in place. And then once they're anchored into that slope, they're not going anywhere. Then here you can see that final surface once the vegetation has been established. So the performance of the GEOWEB system allows it to handle those fluctuations in water depth and the associated changing velocities and shear stresses while preventing erosion along those side slopes. In this case, using a soil and grass that was local to the area, in this case, they actually used excavated soil, is going to help with making it sort of blend in once everything is there so that the GEOWEB panels aren't noticeable. But now you can walk along the shoreline without fear of sinking in, and the shoreline is protected against erosion for years to come. And one more thing that I do want to point out, I mentioned it a couple times, but if you are going over a liner, in this case, this bright yellow geomembrane liner, you can do that with the GEOWEB system, and it's a great way to protect that liner from damage. So you can sort of drape the GEOWEB panels over the liner, use the tendon anchorage system so you're not puncturing the liner with stakes, and now you can fill this in with topsoil, let it vegetate, and your liner is protected, and it's going to do the function that the liner needs to, be impenetrable, not allow water or chemical leaching, anything like that. But now it's vegetated, it looks nice, you don't have to worry about damage to the liner over time, everything like that. And you can do pretty standard maintenance with this, or with any topsoil filled GEOWEB system. If you need to do lawn mowing, you can. A walk behind or a ride on mower is totally fine. Your standard landscaping maintenance is going to apply. Or if you put in those taller grasses like you see in here, you don't need to do any landscaping with that, and isn't that nice? So it's a way to really limit the amount of maintenance that you need to do. You don't have to worry about it anymore, and it's a great way to have that liner, let it do its job without having to worry about it. One last a couple more case studies, actually. I got a couple here. So this was another channel. This was actually in the UK. This was an attenuation lagoon. It was at a former industrial complex that was being converted into a housing development. So the first phase involved constructing attenuation lagoons, which permitting agency required to be vegetated. So due to the expected flows, unconfined topsoil or a typical just sort of erosion control blanket by itself weren't going to be feasible. The flows were just going to be too high. It would cause erosion. So in this case, the 6-inch deep GEOWEB panels were selected as the appropriate solution, and they were anchored with tendons so that they wouldn't puncture the liners, and then filled in with that on-site topsoil and hydroseeded. This is another project. This is out near Sacramento, California. There was a concrete lined ditch and culvert, which were directing a concentrated flow of stormwater runoff into a natural bank in the Brooktree Creek. But it was not only causing severe erosion in places along the creek, but it was exposing the roots of these mature oak trees. So the erosion had also caused the banks to erode and move to the point where they were becoming dangerously close to a homeowner's property. So everything had to be sort of restored to where it was. Once the project was started, construction started by removing the oak trees with the exposed roots that couldn't be saved due to the excavation of the new channel. They saved as many trees as they could, but some of them were too far gone. And due to the proximity of the houses, a normal MSC structure with geogrid tiebacks was not going to be feasible. So in this case, platypus percussion anchors were driven into the bank and then tied off to an anchoring dead man pipe. Kevlar tendons were attached then to the GEOWEB panels and tied off to that dead man anchor to secure this GEOWEB retaining wall. And some geogrids were installed to help support this tall structure as well. We're not getting into the talk of installation or design of retaining walls today because that is a beast all its own, but we do have other webinars about that, or feel free to reach out to us directly, and we are more than happy to talk details on constructing a retaining wall like this. In this case, the GEOWEB footing courses were filled with concrete to provide a non-erodible base because they were concerned about some of those high and turbulent flows that were coming in due to that stormwater diversion. And then the upper courses were filled with topsoil to provide that growing medium so that it would have vegetation. And this is what it looks like sort of immediately after installation, and then giving a little bit of time, letting that vegetation come in. So the system was completed in the fall of 2017, just in time for those spring rains, winter and spring rains, I guess. And then the channel has been exposed to several large rain events since then, and the wall structure has remained stable and the vegetation is becoming very well established. So you can see the photo on the right, pretty much right after that installation, and then the photo on the left is immediately after installation. Photo on the right was from 2022. So 4 years after installation, all that vegetation is coming in. Everything is standing strong. All right, so that was topsoil filled. Now we're going to move on to the idea of doing aggregate infill. So these are permeable hard armor covers, and you can do aggregates, so you can be your stones, it can be really coarse sands, salvaged materials, that sort of thing. So again, testing was completed at CSU. They did both indoor and outdoor flume testing. And the main objective here was to determine how much the GEOWEB confinement can aid in reducing your riprap size. So we looked for how well the aggregate stayed in place during the tests to determine the rock size that would prevent washout, because the system doesn't work if the stones get picked up and moved away. So the results were pretty impressive with the GEOWEB system working on steep bed slopes and allowing for high velocities and high shear stresses. In this case, you could allow for a max of 18 feet per second for velocity, and again, that's 16 PSF max shear. If we remember when we were talking about the vegetated systems, those allowable velocities were around 30 feet per second. So the vegetated system can actually withstand higher flows and shear stresses than the aggregate filled channels. This might seem counterintuitive, but if you think about it, comparing the full grass, the whole root system, the whole lawn of a channel compared to a single stone, you can see where the difference is for that max velocity. And so remember that the main objective was to determine the reduction in riprap size due to the confinement. Plus, vegetated channels can only withstand water on an intermittent basis, otherwise the grass has the potential to die. So if you are going with a continuous flow, aggregate is going to be the way to go. So there are differences between the two, why you might choose one over the other. So Dr. Chris Thornton did put together a design tool based on a regression analysis so that we can compare the reduction in crushed aggregate confined within the GEOWEB panels to a conventional riprap channel. So the tool is based on all of the testing data and allows us to predict the rock loss and the rock size based on those anticipated hydraulic conditions. What it comes down to is that we can recommend the appropriate cell depth and rock size for individual projects so that you can be confident that the aggregate that's placed is not going to wash away. And so here, didn't really zoom in, but you can see how the results can look. Basically, this particular project used a 2-inch crushed aggregate confined in a 6-inch deep GEOWEB panel. And then the tool compares that GEOWEB solution to the riprap sizing using both the ABT Johnson method and the US Army Corps of Engineers design formulas for what their riprap sizes are. So you can see those sizes were 10.3 and 16.7 inches respectively. So for this job, the stone size reduction was between 5 and 8 times. So that's a pretty significant reduction, and it allows you from going from large engineered riprap stones to much more easily accessible crushed aggregate. So the Minnesota DOT used the GEOWEB system to help stabilize the surface around bridge abutments and along railroad tracks and crossings. And so the flexible nature of the GEOWEB panels means that it can easily contour to a slope face and around obstacles such as piles or abutments. And with the system in place, water erosion is prevented around those abutments, reducing maintenance costs. And for this project, it was actually a mixture of topsoil with vegetation and then stone infill. So the stone was being used below the bridges where everything was in shade, grass wasn't going to grow. And then outside of those abutments, out in the other protected areas, they used topsoil with vegetation for that sort of natural green aesthetic. Here's another case study. This one was for the Gila River Indian Reservation south of Phoenix in Chandler Heights, Arizona. So heavy runoff from some intense storms was leading to erosion and flooding in the adjacent subdivisions. Several existing embankments and channel sections had failed under a recent 100-year storm event. Repair time was critical to reduce flooding and prevent runoff. So the channel length was about a mile long, and it routed water to detention ponds and natural drainage areas. The channel area was cleared of existing vegetation, and then the natural sand subgrade was graded and compacted. To prevent infill loss, a non-woven geotextile was installed under the GEOWEB panels. So that's where you might need that geosynthetic underneath the panels. Typically, it's going to be either a non-woven or a woven geosynthetic geotextile. So in this case, that non-woven was used to help separate the stone infill and the native sand subgrade. Otherwise, there would be the potential that the sand would get pushed down into the stone would get pushed down into the sand, which would negate the effect it would have on protecting erosion at the surface. So this was a very wide channel. It was about 100 feet wide in some places with only 3-to-1 side slope, so really quite shallow. And the flow rate was intermittent and slow. So in this case, anchorage consisted of using ATRA anchors, using number 4 rebar, so 1/2-inch diameter rebar, and our ATRA stake clips. And one of the really nice things about the GEOWEB system is that it allows for in-field adjustments. So here you can see the GEOWEB cell depth is actually reduced from 8 inches down to 4 inches. The second half of the channel away from the main inlet was subjected to significantly reduced flow rates and shear stresses. So because of that, less protection is required. So a shallower GEOWEB panel was used, which saved on cost and installation time while still meeting your performance requirements. And this is only possible because of our ATRA key, our mechanical connection device. If you were to use metal staples or plastic cable ties, anything like that, they will not provide enough strength to hold that in place. And over time, those panels will separate, leading to areas of erosion in the middle of your channel. So the GEOWEB panels are very flexible. The panels themselves are very flexible and can be easily cut in the field to allow for pipe penetrations. Here you can see some drainage pipes from a nearby detention pond. And it's really simple to complete those field cuts of the panels to accommodate structures like these so that there are no areas left unprotected. This area right below the drainage weir should be built a little more robustly since this is going to be an area with the highest potential for stone washout due to the turbulence of water coming out of those pipes. So this might be another area where you want to do sort of a mix and match. Maybe you do concrete directly below the pipe outfalls. That way you don't have to worry about material loss in those really turbulent areas, but then transition into stone once you get away from that and get back into laminar flow. So options to choose from, lots of flexibility to make sure that your project is going to get the best possible solution. And just as sort of a rule of thumb for installation, the crew was installing approximately 2,000 square feet of GEOWEB sections per hour with a 4-man crew. Add a 5th man in doing infilling with a mini excavator, about the same. So just something to sort of keep in mind if you're thinking about how long this type of installation might happen. So in this case, the infill was waste rock from a nearby quarry. It means it's not going to be the greatest quality, but that is okay. When using the GEOWEB system, the rock does not have to be the high quality engineered stone. The most important requirement is the size, which we're going to help you determine based on that regression analysis I mentioned, and also that the stone be angular. You want it to have some sort of lockup. That means avoiding things like pea gravel or garden stone, where it's the smooth, rounded stone. That's just not going to lock up over time. That good angular stone is going to lock up to each other, make sure nothing gets washed away. So using infill material that is on site is a great way to save on your material and your hauling costs. Plus, an advantage to using the GEOWEB system is that you can actually drive on it. So if you do the stone infill, you can actually drive on the panels. You can see a fully loaded dump truck in the left-hand photo there. So you don't have to have additional infrastructure during your installation. The GEOWEB can act as its own access road. Keep filling up the panels in front of you with stone and just start driving on them. So it's a great way to save a little bit on that installation cost. And then here is that installation under typical flow conditions. So several drop structures were designed throughout the channel to reduce the velocity before it reached the end of the channel so that the water could be naturally transitioned into the groundwater system. And with the aggregate protection system, there is basically little to no maintenance required. Since that aggregate is going to be confined, it doesn't need to be replaced. And the channel is large enough to accommodate the large storms without overtopping. So now this is a permanent solution for this area, and they don't have to worry about having to come back in and do replacement of the material. Another project here, this was at Billings Logan International Airport in Montana. It was built on a sandstone rock with basically little to no topsoil. Any vegetation growing at this site was imported, and the high velocity runoffs areas next to the takeoffs were causing some pretty significant erosion that needed to be addressed. So the GEOWEB system with aggregate infill was chosen to protect the open channel from erosion during a up to 100-year storm event. And the open graded aggregate would allow for that stormwater to infiltrate through during low flow times into the existing groundwater. So this was designed to also be permeable. In this case, 2 detention ponds were also built to control the stormwater runoff that flows from the channel. And the GEOWEB system was installed over a geosynthetic clay liner to help protect the banks of the pond against wave action and to provide that erosion resistance. So the airport is sloped at your pretty standard 2%. I had some large storm water pipe systems that had to be handled. So with that slope and those pipes, the challenge was lining these open channels and those high flow channels with that pervious material that wouldn't create ponding, but would still provide erosion control. So this GEOWEB system with that clear stone infill was a great fit to provide that desired infiltration without having to worry about erosion at the surface. All right, last thing I want to cover is concrete infill. We're running a little bit out of time, so we're going to go fast. So this is now doing impervious options. So again, testing was done at Colorado State University for those concrete channels. And one of the things that the concrete did was it actually overtopped the flume. So they were running so much water through the flume that it actually came up over the top. So it was more than the channel could handle. So it maxed out that flume at 36 feet per second and a max shear of 21 PSF. So it doesn't seem that high, but the flume itself couldn't do any more. And again, this is one of the top research facilities in the world for this sort of thing. So this was as fast as you can get testing to go. So this is a great way to show that the GEOWEB system, when filled with concrete, is going to be the solution for any of your most challenging projects. It is something we are very confident in. It is the only geosynthetic that ever maxed out the flume at CSU, and that includes articulated concrete blocks, TRMs, gabion baskets, anything like that. So this is the best solution for those most challenging projects. So concrete filled GEOWEB is best when there are going to be those very high water flows. So this was a channel project that took water runoff from a train intermodal yard. The GEOWEB system replaced a design that had 6-inch reinforced concrete channel bottoms and then 4-inch deep grout bags on the side slopes. So the GEOWEB system was a value engineered solution due to cost overruns. And the 6-inch reinforced concrete was recommended in the channels and then the grout bags on those 2-to-1 side slopes, but the owner wanted something new. So the GEOWEB system actually saved the owner a couple $1 million, not bad, but more importantly, sped up construction and allowed the yard to be in service significantly faster than originally planned. So the side slopes of the channels ended up using 3-inch deep GEOWEB. So they went from 4-inch grout bags to 3-inch GEOWEB anchored with stakes. And then the bottom of the channel used 4-inch deep GEOWEB. So it went from 6-inch reinforced to 4-inch GEOWEB concrete. And it didn't actually need any additional anchorage along the bottom. The 4-inch deep concrete can support clean out equipment. So you can drive on this system once that concrete is cleared. So it's another way to have that flexibility and versatility of the GEOWEB system to create the right solution for your specific project requirements. And the GEOWEB panels do act as their own form for the concrete, so there's no need to build additional formwork. And, formwork on slopes can always be a little tricky and usually extends your pour times, your construction times. So the concrete is poured directly into the GEOWEB panels from top to bottom, and then the cells hold that concrete in place and prevent it all from slumping and creating areas of uneven thickness. And speaking of thickness, an advantage of the GEOWEB system is that it assures consistent placement thickness across your entire project area. Pore pressure buildup is always a concern underneath concrete structures, so this project included drilled weep holes through the set concrete to relieve that pressure. There are some other options for relieving pore pressure that you can use as well. Again, something more we are more than happy to discuss with you on a project-specific basis, but just something to keep in mind when you have concrete structures is that you do need to make sure you are relieving that pore pressure. Then here we can see that full extent of the project was covered more than 1 million square feet with the GEOWEB system and saved the railroad a significant amount of money and installation time, all good things. And so then this is one last section. I said the last one was, but this is actually the last section. And it just is highlighting two special cases, including pipe outfall areas and then those really, really high flow situations. So outfall areas can be challenging because they typically have high velocities and really high shear stresses, more than the channel does as a whole. And so the water in these areas is typically turbulent rather than nice and laminar and smooth. And that can cause lots of problems that can help, or that could lift up stone or soil, cause that excessive erosion. So using the GEOWEB system can help mitigate these concerns, especially when you do use concrete in the outfall areas. And so the option to be able to mix your infill types is really beneficial in these areas. Use concrete around your outfall area and then transition to vegetation or stone for the rest of the channel for that great aesthetic appeal. The GEOWEB system can be used in conjunction with large riprap stone as well when there is that potential for high flows. This was a culvert outfall in Milwaukee, Wisconsin. So strong surface protection was placed over the panels. In this case, they used a core fabric, and that can help withstand those high flow events as well. And these are intended for short duration events. So just during your high intensity storm that you'd have these really high flows going over the system. Otherwise, you're going to want to probably go to concrete if you know that you're going to have consistently high flows. So just something to keep in mind. Then the last thing I want to mention is going to be when you need to have energy dissipation. So if you are in those very high flow events, but you need to slow that water down because it's going into maybe a natural groundwater system or into a smaller diversion pipe system, any number of reasons you might need to slow that water down, energy dissipators are going to be the way to go. And you can insert those directly into the GEOWEB system. So you can place them on really steep slopes, shallow slopes, around curves, anywhere that they're necessary. And you can do any number of different ways to put them in. You can form them in as you're pouring the concrete. You could do low tech and just throw some boulders in there and grout them in place. Number of different methods. We can help you determine what, if they're needed, how many, spacing, sizing, all of that sort of thing. That is obviously highly project dependent as to what those are going to be, and you can determine what is going to be the most appropriate way to get those into your system. But they would be used with the concrete filled GEOWEB. You wouldn't use them with stone or topsoil infill because the flows are just going to be too high and too turbulent around those dissipators. So just something to keep in mind. Like I said, there is no one right way to do those energy dissipators or to put them into the GEOWEB system, but we are more than happy to talk with you about what that is going to be on a case-by-case basis. But you can see you can have some pretty intense flows coming down through here. This was actually a project in China that they were bringing water across a really long field, and it was going into a natural detention pond, so the flow needed to be significantly reduced. So all of these dissipators were helping with that so that the flow was pretty much near zero by the time it reached the end of the channel. All right, so in the summary, the GEOWEB erosion protection system is great for channels. It has great flexibility of construction. We have a variety of infills to meet your project needs. We can fill the GEOWEB panels with topsoil, aggregate, concrete, anything you need to help protect against that surface erosion due to high velocity flows. And all of our evaluations are backed by over 35 years of experience and extensive research and testing at Colorado State University. If you are interested in any of that information about the testing that was done with Dr. Thornton, please just let us know. Summaries are available on our website, and then we have more information that we can share as well. So we are happy to share this information. Let it be something that you can use to talk with regulators or other people who are interested in doing this type of work to make sure everybody feels comfortable that these are solutions that are going to function. So part of our complete solution is our technical assistance. The engineering team here, hello, works closely with landscape designers, engineers, owners, contractors, offering free project evaluation services for any type of GEOWEB solution or any of our other products. And so the form is on our website at prestogeo.com. You fill it out with as much information as you have. You can attach documents such as geotechnical reports, site photos, any other info you have, that sort of thing comes directly to us. And then pretty quickly, usually 1 to 2 business days, our engineering team will provide a complete evaluation, and that includes infill recommendations, anchorage requirements, whether or not we recommend that geosynthetic underneath the panels. If we're talking energy dissipation, we're talking that as well. All of the things that you are going to need to get the best solution for your project. And so we do deliver quality and over 40 years of expertise, guaranteeing each shipment meets or exceeds our specifications, so you can deliver certainty and build with materials that you can trust. No disclaimers, no concerning fine print. And a little bit of housekeeping before we get to the Q&A session at the end. For PDH certificates, for listening to me today, you do get 1 PDH certificate. Yay! If you listened live, you will be getting an email from GoToWebinar by the end of the day that will give you a link to be able to download your PDH certificate. Then this webinar is recorded and is going to be put on your webinar dashboard. And that way you can review it at any time, come back, listen to this, listen to the Q&A session that's also going to be recorded. And you can get the other webinars that we've done. We have a whole library of webinars that you could listen to, and you can earn PDH certificates for watching those as well. So that will be an email coming from Presto Geosystems in the next couple of days with information about accessing your webinar dashboard if you've never been on there before. So that's potentially 2 emails that you will be getting. One from GoToWebinar with your link for your PDH certificate, and then in a couple of days, it will not come today, but in a couple of days, you'll get another email from Presto Geosystems getting you on this webinar dashboard and getting you into our system so that you can get other PDH certificates for watching other webinars. As always, check your spam folder if you don't see anything, or reach out to us and we are more than happy to help you with that as well. All right, so here is my contact info. Please feel free to reach out to me for anything. If you've got questions about today's webinar, if you've got questions about projects, even 10,000 foot level, you're just like, hey, is this something that could even potentially work on my site? More than happy to discuss generalities and specifics. So anything that you might need, I am more than happy to talk with you about. I think it's a great thing to just sort of check all of your options, especially if you've never used the GEOWEB system before. So definitely feel free to reach out to me. Now, I have gone pretty much to the end of my time, so thank you everybody who has been able to stay. I am going to answer some of these Q&As that have come through, so I'm going to stay on a little bit longer. If you can stay, please feel free. I'm going to answer some of these questions. If not, the Q&A session is being recorded and will go up on the webinar dashboard in a couple of days. So you can always log back on, check out the Q&A session when you have time. So let's get to a couple of these questions while we are here. Lots of questions about existing vegetation on slopes. So if you have existing shrubs or trees or anything on a slope, do you have to remove them to put this in the system, to put the GEOWEB system down? No. So you can leave trees, shrubs, or other infrastructure if you've got piping or fencing, signage, anything like that. The GEOWEB system can sort of flex around existing things on your slope. You do not have to fully remove everything before you do that. So that's a great way if you do have mature trees or good landscaping or something on there. We can sort of flex the GEOWEB panels around that so that you still get the coverage you need to protect against erosion, but still leave in place what's already on the slope. It's a little bit harder if you want to plant large trees later, because you essentially would have to cut out a section of the GEOWEB panels to be able to plant a tree. Excuse me. Doable. I'm not saying it's not possible. I'm just saying it's a little more difficult. But it is something that can be done, has been done, and going around existing trees, definitely doable. Number of questions about that. People are pretty concerned about making sure those trees are gonna stay in place. So yes, definitely good. Some questions about using the GEOWEB product for infiltration measures, or how does it stay clear so that you can have that infiltration, that sort of thing. So yeah, infiltration is a great way to use the GEOWEB system. So when you use either topsoil or stone, it is considered a permeable system, so water can infiltrate vertically through the system and down into the groundwater system underneath it. If you don't want that, you either need to use concrete, impermeable, or put an impermeable liner underneath it. We talked a little bit about liners and how you can use those, and use the GEOWEB system to protect those liners, make sure that they stay in place. But if you want permeability, that's definitely something as well. Using a clean stone, so something with very minimal fines content, is a great way to get a lot of water infiltration. Topsoil doesn't infiltrate quite as fast, but soil will absorb that water and let it flow down through into the groundwater system just a little bit slower. So it's definitely possible and definitely something that we see a lot, especially on when you're in cities or in areas where you've already sort of reached your impermeable hard surface limits. You already have enough parking, roadways, that sort of thing, that your landscaping plans say you can't have any more impermeable surfaces. This is a great way to have that permeability. And you can basically accept water runoff onto the GEOWEB system. It's protecting against erosion. That water flow isn't causing erosion around your roads or your impermeable surfaces. It's collecting the water. You can direct it because it is a channel, but it can also let the water flow naturally down into the groundwater system. So definitely doable, great application for the GEOWEB system. Some flexibility with it, whether you want topsoil or stone or granular material, that sort of thing. If you are concerned about the hydraulics of it, that is something where I urge you to read the research summaries that came through from Colorado State University, or reach out to us and we can talk through that. Yes, essentially, permeability is a great thing. Let's see some other questions. Some questions about extreme environment conditions. Seen a couple of both cold weather and hot weather, but also extreme weather, hurricanes, that sort of thing. So cold weather and really hot weather are not a concern. The GEOWEB panels are made with that HDPE, high density polyethylene, which is a chemically inert plastic. So it's not going to leach or degrade plastic or chemicals into the system, not even under hot conditions or cold conditions. It's not going to become overly brittle and crack in the cold. It's not going to become overly hot and potentially melt or anything like that in the heat. It can handle a very wide range of those temperatures. You can't set it on fire. I'll say that. It is plastic. It will melt under fire. But just standard environmental heat. If you are in a very hot environment, we've done stuff in the American Southwest, it gets grossly hot down there. So the heat or the cold conditions are not a concern for the GEOWEB panels themselves or any of our accessories. They can have snow buildup or ice buildup on them. They can handle frost heave of the ground because they are that nice flexible system. As the ground heaves during the freeze-thaw cycle, the GEOWEB panels can move with the ground without becoming damaged in the way that, say, like a concrete surface would be during frost heave. The panels can sort of move with the ground during those conditions, so that's not really a concern. And then during extreme weather events, I mentioned there were those hurricane channels, but also it's significant water hurricanes. What are they in Asian typhoons are a very similar type of extreme weather event that can happen. So if you're along a shoreline or the coastline in a country where hurricanes or typhoons or any of those sort of large wave action events happen, this can be a good way to try and mitigate the damage that comes from that type of extreme weather. I'm not saying they can withstand any type of, all types of hurricanes. That's a really broad statement, but they can definitely help mitigate some of the damage that can come from that. That one is going to be a really case-by-case basis. I will say that I don't I don't have any specific numbers or anything that I can throw out for that, but I can say it is something that we've encountered and we've handled, and we've put the GEOWEB system in those types of environments. So if you do have questions about that, I urge you to reach out to me and I'd be more than happy to discuss it with you. Some other extreme weather events, you know, like I said, fire, not great. If you are, you know, unfortunately like California right now, who is desperately on fire, that's not good for anybody. And frankly, I don't think the GEOWEB system is going to be the most important factor in all of that. But just standard heat, not a concern. Wildfires, yeah, it's going to melt plastics. That's just how wildfires work. But other environmental concerns, you know, the high wind events are not a big deal. Anchorage is going to hold everything in place. It's not going to really be exposed for that. The GEOWEB panels themselves do have UV stabilizers in the resin so that it can be exposed to sunlight without becoming brittle or crack or degrade. So there's no worry about basically exposure to the elements, or if you're in a high pH soil condition, that's not going to have any negative effect on the GEOWEB panels. They're really, I mean, basically, yeah, they're chemically inert. There's nothing really that's going to damage them in your standard environmental conditions. So kind of rambly, but hopefully that answered some of those questions. Let's see, some questions about so the long-term pollutants and plastic degrading. So no, they're not leaching chemicals or plastics. They're not releasing like little microplastics or anything like that into the environment. It is that's the benefit of using that virgin high density polyethylene, is that you do have control over that, so that you know that you're not contaminating the ground or the groundwater system with this by frankly putting plastic in the ground. You're not damaging the ground or the groundwater system around it. So we've done testing on it. It is not a concern, but it's a great question. Let's see, some questions about, let's see, I'm going to do one more question because I've gone over my time. So thank you, anybody that's sticking with me. So questions about how the panels handle those high flow conditions, and how you might I guess model those. So what's the Manning's value and N value for that sort of thing? And basically you're going to use an N value, a Manning's N value of whatever the material is, regardless of the GEOWEB panel. So topsoil with vegetation already established has a typical Manning's value of 0.023 to 0.026 off the top of my head. That's what you would use when you are running hydraulic flow calculations with it. The GEOWEB panel does not affect the Manning's value. So the flow through your channel system in your wetted perimeter is not going to be affected by the GEOWEB panel. I hope that helps. I'm more than happy to talk calculations with anybody. I'm doing it without looking at anything right now, so I'm going to stop before I put my foot in my mouth. But we do have information about it. I'm more than happy to talk about it with you when I have that information in front of me. I hope you can understand, but definitely reach out. There's a couple of you who asked questions about that. So yes, we have those values. We are happy to share them with you. But with that, I have gone significantly over my time. So I thank anybody that has stayed with me. I hope you all have a wonderful rest of your day, and stay warm and don't freeze too much, and that we see you at future webinars. Keep an eye out. So bye, everyone.